Hello, this video is going to cover section 4.2 on graphing linear equations. And so we're breaking this section up into 2 days. And so for this day 1, the idea is just to, or kind of our goal, is just to be able to determine whether an ordered pair is a solution of an equation, and then to be able to generate some solutions of equations. So the first thing we need to talk about is some vocab. So something you'll hear a lot, and it's in the title of this section, is the word linear equation. Okay, and all we mean by that is an equation that can be written in the form and we say ax plus by equals c. And so in linear equations, a, b, and c are just numbers. So for an example, we might have 2x plus 3y equals 7. That would be an example of a linear equation. And you'll notice in our linear equations, our exponents of our variables are just 1. You won't have any other exponent. Now here, for solutions to an equation, this is hopefully familiar. We did this back in chapters 2 and 3 when we were solving equations that looked like, let's say like this, x plus 4 equals 5, and a question might have asked us to check if x equals 1 was a solution to that equation. And so back in chapter 2 and 3, we would have plugged that in for x to get 1 plus 4, and since 5 is equal to 5, we knew that was a solution. So it's the same idea here, except now in my equations, I have variables x and y. So now our solutions are going to look like ordered pairs. So a solution is going to be an ordered pair, and we know those look like x comma y. So it's an ordered pair that makes the equation true. Still looking for what's going to make that equation true. All right, next is function form, and we'll be working with this especially in a few lessons here. So function form is when y is isolated on one side of the equation. So in other words, it should be all by itself on one side of the equation. So if we look at the form of a linear equation I gave you here, this would not be function form because I have x and y on the same side of the equal sign. Something in function form might look like this. Y equals 2x plus 1, because what we have is y all by itself on that left-hand side. Okay, and the last piece is the graph of an equation. All the graph is the set of all points that are solutions of an equation. And so this is a bit new. Back in chapter 3, when we were solving these types of equations, we only really had, well, in most cases, we had one solution. We did look at some cases where we had an infinite number of solutions, and those were our identities. But now when we're talking about these linear equations, we could have an infinite number of solutions. And if I were able to plot all of those ordered pairs, that's what my graph would be. But we'll get into more of that later. So here's our first goal, is to be able to check whether an ordered pair is a solution of an equation. So for part A, my equation is 2x plus 3y equals negative 6. And I want to know whether the point 3, negative 4 is a solution of that equation. So all we're going to do, we know our ordered pair looks like x comma y. So all I'm going to do is substitute my 3 for my x value, my negative 4 for the y value, and see if it really equals negative 6. So it's going to look like this. I'm going to put parentheses to leave a space for those values. And again, for x, we said we were going to plug in 3, and for y, -4. So now I'll plug that into my calculator. So we're going to plug it in exactly how we see it. So 2 times 3 plus 3 times -4, and we get -6. So since -6 is equal to -6, we check out, and we would say 3, -4 is a solution. Okay, so let's try another one. Again, I'm just going to label this x, y, so we make sure we keep that straight. I'm going to recopy this. 2x plus 3y equals -6. Again, I'm going to leave a little placeholder for my variable. And let's see, this time for x I have -4, and for y I'm going to have 1. So again, I'm going to use my calculator here. Sorry, I keep making the page crooked. And let's see, I have 2 times -4 plus 3 times 1, and I get -5. Now in this case, that's obviously not equal to -6. So since that is a false statement, I would say -4, 1 is not a solution of this equation. So next we have 3 examples for you to try. So I would pause here, and I'm not going to talk through these examples, but when you unpause it, I'll have the work to show you so that you can check your own work. Okay, so here's the solution to those 3 checkpoint problems. And so something I wanted to point out, we talked above about how these linear equations are going to have an infinite number of solutions. So I just wanted to show you here. Here's an example where we've found 2 solutions to these equations. So we're going to have more than one. So if you have any specific questions about those, you can feel free to ask. But for the meantime, then we're going to keep going. So on the next page, now things are kind of turned around a little bit. Instead of giving us an ordered pair and asking if it's a solution, now we need to find our own ordered pair that's a solution of the equation. Okay, so our directions say to find an ordered pair x, y that is a solution to the equation. So when I'm asked a question like this, I like to make my x value 0. So I want to find an ordered pair 0, right? And we're going to find the y value that's going to be a solution to each equation, because it just makes 0 makes things a lot easier to work with. So here's what I'm going to do. I know I want my x value to be 0. So I'm going to do 5 times 0 minus y equals 7. And then I'm going to simplify that. I know 5 times 0 is just 0. So what I have left is -y is equal to 7. Now we know from our solving days, if I want to get y by itself, I need to divide both sides by -1. And I'm going to get y is equal to -7. So my ordered pair, I plugged in 0 for x, so my x coordinate is 0. My y coordinate will be -7. So I know that 0, -7 is going to be a solution to that equation. Okay, let's try another one. Again, I'm going to stick with x equals 0. So now I have 0 minus 3y equals 3. Well, that 0, really that means there's nothing there. So I have -3y is equal to 3. To solve this, I'm going to divide by a -3. And I'm going to get y is equal to -1. So for this problem, 0, -1 is a solution. So go ahead and pause the video and try the next example. Again, let's stick with making our x coordinate 0. Okay, so I'm going to plug in 0 for my x and copy the rest of the equation. Again, 3 times 0 is 0, so that really just goes away. And I have negative y is equal to 6. And if I divide by negative 1 on both sides, I get y equals negative 6. So now my ordered pair is 0, negative 6. So that's how we're going to find a solution. Since they let us pick, I just picked an easy number for my x-coordinate and always used 0. Okay, the last piece, and again, we're working towards being able to graph these equations. So the last thing we want to be able to do is to create a table of values for these linear equations. So in the examples above, we generated 1 point, but I want to be able to generate more than 1 point so that ultimately I can graph these lines. So that's what we're going to work on here. Now, in each case, they gave us an equation. And these, just to kind of think back to the vocabulary, these all happen to be in function form. Because if I look at everything, y is by itself on the left-hand side. And that's going to actually make it a little easier to generate these tables. So now, I want to find 4 points for each equation. And I'm going to do that by plugging in these x values into my equation to generate the y values. So let's go ahead and take a look at that. So let's work with negative 1 first. So if I want to find y when x is negative 1, I'm just going to plug in negative 1 for x. So I have 6 times negative 1 minus 2. Again, if you need to use your calculator, especially because those signs are going to be so important to getting this right. So I have 6 times a negative 1 minus 2, and that's going to give me a negative 8 for my y value. So I'm going to put that in the table. And really what that means is that negative 1, negative 8, it's a solution to this equation, and it would be a point on the graph of that line. And so then I just continue the same way through the rest of my x values. So now I have y equals 6 times 0 minus 2. If I plug that in, that's going to give me a negative 2 for y. Next, I have 6 times 1 minus 2. Well, that's just 6 minus 2, which is 4. So 4 is my y value. And last but not least, I have 6 times 5 minus 2, which is 30 minus 2, or 28. So in the interest of time, I'm not going to go over part B, but I do want you to try this last example. So pause the video, and then I'll show you the solution so you can verify your work. Okay, so for this one, I have my same values here, but now I have a new equation. So again, I'm just going to be careful with my signs. So I'm going to take negative 2. My first value is a negative 1 plus 5. Again, my negative times negative is going to make this positive. So I have 2 plus 5 is equal to 7. So my y value should be 7. Then I have negative 2 times 0 plus 5. Well, 0 plus 5 is going to give me 5. Next, I have negative 2 times 1 plus 5. Negative 2 plus 5 is equal to 3. So my 3 goes here. And then for my last point, I have negative 2 times 5 plus 5. So negative 10 plus 5 is going to be a negative 5. And that would complete my table. So that's as far as we're going to go today. Tomorrow, or in the next video, we'll look at how we use that table to then produce the graph of these functions.